Dear friends, in this video, I'm going to discuss part 2 of Walk the Talk in the context of logistic regression with a practical example. We have already done part 1, where step 1 in the analysis of logistic regression was covered. Now we are going to do step 2 and step 3 in part 2. Let us recollect the example, the same example of the data set on 100 customers, two predictor variables, spending and having the Simon credit card or not. The target variable is purchase, 0 or 1, binary type. 1 is equal to purchase, 0 is equal to no purchase. Now we are going to discuss step 2 and step 3. Step 2, McFadden R squared. McFadden R squared is defined as R squared is equal to 1 minus log likelihood full model divided by log likelihood null model. And by substituting the values of LLF and LLN, we get, on simplification, McFadden R squared is equal to 0.101250. So this is log likelihood full model. This value is log likelihood null model. We have got it from step 1. You may kindly see the video. So what does it mean? It means only about 10.12% of the variations in purchase behavior pattern 0 or 1 has been calibrated or explained by the full model. Obviously not very robust, but acceptable. Please note that logistic regression model is non-linear in nature and does not behave like the ordinary R squared involved in the ordinary least square regression. In other words, the R squared in the ordinary least square regression is not going to be of a higher order in logistic regression. It's very rarely R squared will be very high, and therefore what we have to understand is this 10.12% acceptable? Yes. Is it very robust? No. And you should see it with caution. At the same time, if it falls below 10%, let's say 9%, then the veracity of the model can be questioned. This is McFadden R squared. In other words, the two predictor variables, spending and having the credit card status of the Simon card, together explains only 10.12% of the variations in the purchase pattern. This is step 2. Now let us look at step 3. Test for significance of individual coefficients. We have already tested in step 1 overall validity of the model, where on the overall basis there is a logistic regression assumption quite valid. Now we have to test whether the individual variables are significant, and the output, Python output, is displayed here for ready reference. Constant spending card, and these are the coefficients. Then the p-value is displayed here. For a moment, let's not worry about the constant. The interpretation part is extremely critical for spending and card, that are the two predictor variables. These are the coefficients. So if you write this as an equation in Z, Z is equal to minus 2.1464 plus B1 times 0.34165. I think the B1 appears here by a typo. Let me omit it here. Actually, B1 is equal to 3.1416. So minus 2.1464, the constant, plus 0.3416 pending, plus 1.0987 card. So this is your B0, this is your B1, this is your B2. So the coefficients are highly significant. In other words, B1 and B2, as well as the constant, B0, they are highly significant. At 5% level, if you take alpha as 5%, they are substantially significant at 5% level. Hence, we infer that spending and card are important predictor variables for capturing the behavior of purchase pattern, predicting 1 or 0 in terms of the purchase behavior. In other words, whether a customer will buy or not is definitely going to be impacted by spending and card. So, ladies and gentlemen, I stop here the part 2. We will go to part 3 very soon. Thank you very much. I hope you have enjoyed. As I say again, you have to see all the 3 videos once it is fully covered. That is part 1, part 2, and part 3. I propose to conclude the conceptual framework of logistic regression with a practical example which we are seeing by part 3. That is the next video. Thanks a lot once again.